And thank you all for coming to the afternoon slot with the wonderful Bell soundtrack, and we've got this all going on now. I just want to do a quick survey of how many people in this room already believe that they have their database in their DevOps pipeline. No, sorry, this wasn't meant to be no accusations in this, just a kind of a level-setting thing for me to know who I've got in here. And how many of you are working in DevOps teams at the moment? And have aspirations to it, yeah, there we go. All right, well, thank you very much for coming today. I'm Elizabeth from Redgate. This is not a vendor session though, so if you actually expect demos, apologies, you'd have to go to the booth for that. This is just my chance to talk to you about some of our observations that we've made as we've done our research and worked with a bunch of customers. So in a way, it's more like a research readout, and you are here being my peer reviewers. So I'm very much looking forward to what you make of our perspective on database DevOps. I come from a development background. I used to work in design management, in CAD design management, and so my whole career has been basically managing changes through automated systems into production, and now I'm the portfolio manager at Redgate, so I manage the team of product managers. And in my time there, I mean, I've worked with literally hundreds of customers who are somewhere on this journey trying to automate database deployments or just trying to bring some better practice to their databases. And so the genesis of this particular talk was actually last year at Continuous Lifecycle when I gave a talk on automating database DevOps, or automating database deployments, and it was the wonderful kind of one way. So you're making your database changes over here in development, and you're trying to get everything into production. And that was the talk I was giving, is how to bring it into your pipeline. And somebody asked me the question and said, we're already doing that, it's great, but what we're really struggling with is bringing data back from production into the process. And I went, that's really hard. And a year later, I've come back to give what I think is a way better answer and talk about what we've discovered in the last year to try to answer this problem. So this is the closing the loop part. Again, I think that first part, and I'll talk about this a bit, but not in huge detail, about getting changes out to production, is actually quite well understood now about what good practices for that are. But how to bring information back and actually let that feed the pipeline, that's where I think a lot more action is and a lot more of the interesting questions are coming up today. So I'll take us back then I'll sort of go quickly through that first part about database, bringing the database into the pipeline in the first place. And I hope you'll permit me my visual pun, because data is hard and come on, after lunch crowd is so hard. Hard and valuable, like a diamond. So database development is obviously different from your application development because there's data. And the data is a really precious business asset. You get everyone interested in this question. And the concerns around it are very protective in a way that application development isn't. Changes are hard to roll back because changes are often one-way transformations on that data. And obviously, the change itself may have performance implications, as well as causing performance changes in the way your database is performing. And it's really hard to test. Like everybody, people already balk at application unit testing, but then you get into database unit testing and upgrade testing, and you find people like, whoa, I'm out. And obviously, that test part is really critical to bringing it into your pipeline. So all these things make it much, much harder to do database than for the application. But the goals are all the same. Like the thing we're trying to achieve here is still the same thing as for application continuous delivery. We're trying to bring those changes into the pipeline to get frequent low-risk changes. So we want to continuously integrate our changes, just like for the application. We want to automate the testing and the deployment so that, again, just like the application, we get those benefits of rehearsal and reliability. And then rehearsing the releases, so making sure that by the time we get to production, we've already been through this a bunch of times and making those production releases nice and boring the way we really like them. So for the business, they get this agility and reliability. But of course, for us down from that top level, it's as much about not having to work weekends as it is for all of those wonderful changes of speed and throughput. But it's not different. We're trying to bring the database in to get these same benefits. So the database and DevOps. So there are two kind of places where the database, two kind of general zones where the database is coming into DevOps, like I was saying. The first one is you want to make database changes and put them through a similar pipeline as for your application. So this is the dev to prod thing. And then, of course, you do your monitoring, which is a critical part to make sure you know how everything's performing in production. And I give this one a check. Again, I think, basically the world has figured this out, at least conceptually. There's still details, it's still hard, but the problems are no longer deep and conceptual. Whereas the spinning up production-like environments and bringing realistic test data back, these are the things where, especially in the last year, we've seen a lot of action in this area, a lot of development, a lot of new ideas, a lot of things coming through about best practice. So I'm going to talk a little bit more about that. But again, I'd like to talk through the first part so that you know what I'm talking about with database DevOps in the first place. So here is a conceptual model of change. These are not meant to be systems that are kind of interacting with each other, but this is how you can think of changes flowing through for a database, similar to an application. Normally, people will make changes on an actual database when they're developing, and this will usually be in the context of developing an application. So they're making a change on their application that requires some kind of database change here. And then commit it to source control. Talk in a minute about what you're actually committing to source control, but take it on faith, like something goes into version control. Woo. That will go into continuous integration. That will run some automated checks, just like application continuous integration. But here you don't have the same step of building out artifacts. You're running it through those validations. Then you go into release management, where you want to push those database changes to your progressively hardened test environments. So, for example, it might go initially to a first QA environment, and then eventually to all the way through to performance testing, security validation, and finally to some kind of staging environment and to production. So you're taking that artifact of those database changes and pushing that out to the environments one by one. And then you go around from production and monitoring, and then back through trying to provision the database environment. So this is for databases, for data, a sort of conceptual loop about how changes happen and how that cycle works. So now here's where I can go into details about application versus database continuous delivery. So when I use these concepts, which I'm kind of assuming, given you're at a continuous delivery conference, you all have some idea about those basics. So I hope you're okay with me not going into great detail. If you're not, we can talk about that afterwards. But what those artifacts are for the application, you're checking in your source code. For the database, you've got to be checking in your change script. We've become opinionated about this, or I've become opinionated about this over time, because we used to take a view that, well, it might be the schema, the state of the schema of your database, and you could use desired state configuration. Oh, it might be a migration script, and however you want to work is fine. And that is true. But if you want to get to the full DevOps answer, so that ultimate state where nobody is actually modifying the thing as it's going through the pipeline, then it's got to be the change script. You've got to be making the change using some change script to your database eventually. And if you want DevOps that doesn't affect that downstream in the pipeline, if you want no further modification, then that has to be the artifact that developers are working on. So the state is really useful as almost a safety net to try to make sure the changes are doing what you hoped they would do on that. But you do really need that migration script to be present. I know I've glossed over this, in quite high level of state versus desired state versus migrations. But there are whole talks that go into just that subject, and it is quite a holy war. But for kind of pure DevOps, for that ultimate end state, though, you really do need that migration script early. What a build means, so this is the generation of those artifacts. Well, you're not generating any artifacts once you've got that migration script checked in. There are no further artifacts you need to be able to deploy that. So there's no part at which you need to build an artifact that then gets deployed out to the places. So there isn't, for that model, there isn't a built thing. What you're actually testing in CI is quite similar, but you will also need to do upgrade checks. So it's not just your unit tests, which if you have logic in your database, you'd better be unit testing it. Shouldn't come as a surprise. But you also need to make sure that when taking a database from one state to another state, that it behaves the way you want it to. So it's not just testing that the thing gives the desired end result, but also that you can take a current state of the database and bring it up to that desired place you're trying to get to. This is also a place where you can build in that static analysis, just like for applications, where you might have some other checks, some other complexity checks, some other style checks, anything like that you might have. The same applies to the database, where you can build in sort of just rules that make sure that you're using whatever best practice is for your organization. And security checks. So there's a DevSecOps talk just after this, which, sorry, I shouldn't use that phrase. He's continuous security, because we don't like DevSecOps as a phrase, not as a concept. But that's it's during this as well that you can start building in your checks to make sure that the permissions are behaving the way you want to make sure that you've got things encrypted, to make sure that it's all doing the right stuff. And so that's actually all of those validations you can do on immediate check-in. And then deploying itself, it's very easy in the application case. And in the database case, you need to actually run those scripts, run those migrations to get the database up to the level you want it. Now, as I said, this might be more complex than simply, running the migrations. It might be something that takes quite a long time. And so there are times when this needs to be dissociated from your application changes and run ahead of them. But again, that's just a fact of database deployment. You can take a view of things trying to go in lockstep at all times, but there will be some changes where that's just not possible, where you have to do it differently. So that part, that's a whistle-stop tour of that part. Again, there are plenty of resources out there to dig more deeply into this now, and I can point you at some of them again afterwards if it's an area that's not familiar and something you're really interested in. So that's pretty well known, and it all works well as long as you follow the rules. And this starts to get harder the more you decide you want to try to break the rules. And I think this is true of a lot of things in continuous delivery, that if you kind of go all the way, commit to master, and all of these, if you really go fully for it, then a lot of the concepts work neatly. It's as soon as you try to deviate from it that you introduce some complexity to it. So for databases, database CD, the rules are version control is the source of truth. So you might think that what is in production should be the description of what should be in production, but with this model, then you need the version control to actually contain that source of truth, because those changes go out that way from development through the environments, get tested, and then go into production, which means that nobody changes the database by hand in the ideal world, or if you do, then they better actually roll that back into version control really fast, because again, if you might find that change just gets wiped out the next time something goes through the system. No deployment script changes post-development. So this is the case I was talking about where, in many cases in real-world database development, a developer develops and then hands a script off or a batch of scripts off into a release that a DBA will then shape into something suitable for deployment. And for continuous delivery of databases, that smarts needs to happen earlier. It can't be, this is the DevOps dream, right? The database administrator becomes a coaching role into that development team to try to make sure that those changes are properly considered up front. And finally, dev and test using production-like environments, which is that line that got me into so much trouble last year. But it's true, if you want to have that hardened level of changes, if you want to make sure that the thing you are eventually deploying has been really properly tested, then that's incredibly important for database testing. And I'll talk a little bit more about why that's quite so important. And I will admit that this is, for most people, an aspiration. We talk, like I say, with hundreds of customers, and that dream is a real minority of people. A lot of people are trying to bend the rules, but I can assure you that you will introduce complexity. It might be complexity that you're willing to embrace, but it does get more complex the more you deviate from that kind of pure view of database continuous delivery. So that part, we're going to call that done. Maybe not done, but done enough for now. And the part where you monitor your databases and all of that, come on, that's done, right? I mean, we've been doing that for years. There's nothing else to say there. That's just a part of ops. So there's nothing sort of particularly new apart from making sure that data is available to your developers so that they can look how something does behave in production. But then we get left with this bit about supplying environments. And like I say, this is where it starts to get a little bit hairier. So this thing where we need to spin up those production-like environments or sufficiently production-like environments and bringing real or realistic test data back into the pipeline. So it's those problems that I want to spend a bit more time on. So bear with me a minute. I'm going to break this down into 3 subproblems. So what we're actually trying to do here is we're trying to get a usable database. So a thing, an actual installed thing that we can interact with that is a database of the right flavor. We need to get it up to the right version. So this is making sure that whatever migrations and things we need to do, get it up to the thing that we're trying to test, either directly or with an application. And we need to get some data into it. So there are actually 3 kind of sub-problems here. And this goes down to the fact that when I talk about database changes, and the difficulties of database development, we're not just talking about things which are just straight development. This is a development and infrastructure piece, and it shows its dual nature in various ways. And so we need to consider, actually, when we're trying to spin up environments, that problem of getting a database, that problem of getting it to the right version, and the part where we need to populate it with some useful data. So I've got, you can't read it very well, I've got past, present, and future. But you can, ugly orange for the past, back when we had, bad cars and stupid haircuts. The present version and a future version. Now, I know containers is not future, but again, if you look at the people who were saying in the keynote this morning, yes, I'm using containers, it wasn't everybody, right? We're not all there yet. And so although it is happening, I still think for the mass of people, this is a future sort of thing. So the way people got databases back in the old days is, the DBA, somebody went around from computer to computer for us developers and installed one, and then went to the test environments and installed one. And so it was all really manual. And there's still a lot of that going on, of course. What I call the present, we at least have scripted installs or virtual machines. So some other ways of trying to get the databases out. Virtual machines are where you start getting the advantages of manageability into this. So up here, it's kind of, the wild west of databases flying around your organization. From here, we start getting some benefits of being able to centrally control and visualize where our data is actually gone. So present, this is what we see a lot of, but future containers. And I think a year ago, I would have been like, oh, it might happen, we'll see. Not sure that technology, we'll see. And now, a year later, I take a completely different view. I mean, the stories that people are managing to tell with containers and the things that some early adopters are managing to achieve are really, really impressive. So hence calling that future rather than possible, watch, kind of Gartner style. I think this is the way that we're going to be going for provisioning these databases, especially into these environments. And so, for example, one of the things recently is an example, this came from an Eric Kang talk, who's a Microsoft product manager, program manager as they call them, and he looks after SQL Server and one of his responsibilities was SQL Server on Linux, and was explaining what they're doing for testing SQL Server on Linux, and they've containerized this whole thing for the testing, and so this talk, by the way, which is really worth watching, I'm not going to play it now, it's an hour long, it's really worth watching because it goes through in exact detail about setting up an automation pipeline and provisioning the environments with Kubernetes, and it's really detailed about how to do this, and they have open source in GitHub code to actually show you how to do this too, so it's absolutely fabulous for a detailed analysis of how to do this. And so, so this is how they are doing the SQL Server on Linux testing. They are spinning this up in the cloud in these containers. And there has been, over the past year, a lot of debate on, should you, shouldn't you, should you, shouldn't you, and some really great, if you Google sort of should I do my database in containers, you see some really great arguments going on, like Hacker News or whatever, arguments about, well, you definitely can't, because reliability is terrible, and data access is slow, and you absolutely can't do this, at which point, 100 people who have successfully done this in production pop up and say, no, here's how you go. So again, it's a great idea to do this if you want to find out more. And their argument here is, although there are problems, technical problems with containers, the reliability engineering that you're doing for your database anyway extends to the database in a container. And so, there are answers to these things. And similarly with data access, if you're worried about data access, you might already have stuff in memcached, and it's already, like, the mechanisms are there for doing this in containers. The technology is good enough. And so we're actually seeing this happening for real. In this case, he's not actually doing this with a view to running SQL Server on Linux in a container. And so this is one of the things that has also been kind of controversial about whether you can use containers in test only, but not in production. And obviously, having different infrastructure in your test environments from your production environments introduces some potential instabilities and undermines how much you've actually kind of hardened things with realistic environments. But as I say, where we're looking at a world where it is becoming plausible to be running your database in a container, then I think this is shifting, and the discussion is shifting some. So that is the past, present, and future of getting a usable database, spinning up a thing that is a database that we can actually interact with. The next thing about getting it up to the right version, as I said, we're applying the changes from version control. So this is in the pure DevOps case, migration scripts. In some of the, if you have more of a separated dev and ops automated case, it might still be desired state. But regardless, we have a way of applying our changes from the database to get it up to the right version. So solved problem-ish. But then with data. So this is, and again, this is where it starts to get really interesting. So, the question, wait, how do I manage those test environments? That question that made me, the gorilla, go, shoot. And so, when we talk to people who haven't necessarily thought hard about this, the answer is we make backups and we restore them, and that's okay, right? And I mean, there are processes around this that work with restoring backups, and it's still by far, I think, the most prevalent thing we see in people trying to solve this problem today. But we also run surveys which show that the time spent doing this is going up and up and up for, often for the database administrator or whatever ops person is responsible for doing it. It's a really time-consuming activity, and especially as environments are considered to be more and more disposable, it's something which is, it just is a real time sink. And so it's starting to get to an untenable level, even for people who aren't worried about this as a mechanism. That's not even to mention, though, the space considerations, which in many cases, if you're restoring whole databases everywhere, this starts to get out of hand. And then, as we were talking about earlier, the manageability of it. So there's a problem that we read about in the database DevOps press, such as it is, but about data sprawl and about the lack of control of data in your organization. And that feeling that you've just lost the control over what's going on out there. And of course, there is the question of security of that data. And in this, I'll be talking more about GDPR in a minute, but it's not just that, right? I mean, there have been so many data breaches. So this particular case I picked to show because this was an actual case of test data from production being used in a test environment that they didn't properly secure, that then leaked 800,000 names and addresses of families. So it is exactly this case of having used restored data from backups to try to get this effect, to try to get that real testable data, but with a terrible effect to it. So no, in short, restoring backups nowadays, probably not okay anymore. Sanitized backups, not so bad, but that thing about just taking something from production and straight through into developer environments, no. And so again, talking about where the action is in this, the data virtualization technologies and masking technologies, and to try to make sure that you can actually bring the data in without blowing your storage budget, and trying to transform that data in such a way that you actually mask anything sensitive or anything personally identifiable. And so these technologies are actually really, really interesting. And there are a bunch of companies out there, Delphix, Activio, and things who've been doing this for years, and my company more recently. Trying to make this into a managed spread of information so that you can actually manage a useful set of data for your testing purposes. So back to the question of production data and dev and test, really? I don't know, where does this group stand on this? How many people think, yeah, that's a really, masked, yes, that's a really good idea, I want that. Yeah, okay. Okay, yeah, I kind of want it from there. And who thinks it's a really, no, regulated, no. Okay, well, we ran quite a large survey. It was a couple thousand respondents. And so is it desirable to use production data in dev and test? And around 83%, which actually is slightly higher than this room, I think, thought that it was yes, we really want to do this. We want to be using production data in dev and test. And then quite a few people, though, believe that they're restricted from doing it for one reason or another. And so back to this argument about should we, shouldn't we? Well, the pros of using production data in dev and test just go back to this principle of database DevOps, well, of any DevOps, which is that you need realistic test environments so that you really believe that the thing you're deploying is safe, is reliable. And it's important because we know that a bunch of the problems that people encounter with their deployments come from specific data that they weren't expecting. That's a really common problem out there. So for that reason, the only way to get an actual rehearsal, the only way that you're not going to be doing this on weekends and having horrific deployments is for you to bring sufficiently realistic data back in. So that's the pro for it. That's the strong, compelling reason for why you want that in your environments. And the cons, as talked about earlier, is 2017, which really was the year of data breaches, this feeling that you've increased the attack surface of your entire entire estate somehow by bringing that data back. And again, not all of these are from test data, but you do see that, I guess at least 1 in 4 is because somebody didn't manage test data properly, because somebody had some process where they needed to recreate environments, either for continued testing or for bug reproduction or for something that got data into the wrong hands at that point. So the cons are very much about the risk of doing it. And also, we has the follow-up question about, okay, if you think you're restricted, what are the reasons? And generally, it's that data sensitivity one, which means that the thing that they're actually using is not something that they can use, that you can bring into tests. You just can't have that data. Regulatory requirements high up there as well, and of course, storage. So those top 3 concerns about why might like it, but not going to happen for us. Curious for the folks in the back whether did that more or less match what your reservations were? Yes or no? Yeah, okay. Some of you not answering. Because most of the people who said that they didn't want it were back there. If you're wondering, up here in the front, we're like, yes, I think it's a great idea. And so the reasons are, well, the data is either too sensitive or I'm just not allowed to. Legally, I cannot do this. And enter the GDPR. So again, I just want to kind of get a read of the room. How many people here have been involved in a GDPR project? Yeah. Oh, there's some who haven't. Wow. How many people here were already compliant? So they didn't have to? Yeah. Nice. So the General Data Protection Regulation, which comes into effect in what, 8 days? Or rather, it becomes enforced. Yeah, I know, having a look, it's getting close. And this is the regulation, as most of you are well aware of, that enforces new controls on how companies manage personal data. And it gives the people whose data it is, the right to privacy, the right to access, the right to consent, and all kinds of new rights that these businesses have to make sure are baked into their processes, all processes for handling data. So this is a big thing that's been foremost in people's minds about using their test data, even the processes they used to have, and doing that restoring backups thing. What's this going to mean when GDPR really hits? And so back when I pitched this talk, the reaction to GDPR was mostly like this, where you basically had everyone going, oh, it's going to ruin everything. I'm going to lose access. It's going to be terrible. And everyone was miserable, apart from one guy who was saying, yay, finally we're going to manage our data really well. It's really terrific. And actually since then, so that was like 4 months ago, since then, the tenor among the people we're talking to has really, really changed. And we find people saying, yes, this is exactly what we needed to manage our data right. So we used to actually have a name for this persona. He was the data Bolshevik. And he was trying to, transform the way we handle data so we're a mature, but he was so rare. We just never encountered this person who was that passionate about making sure data was handled in a mature way in his organization. We just didn't encounter it. And now, again, we're getting a lot more people who are broadly thinking, this is a really good thing. And so I can tell you some of the ways where people have said, this has done a really good thing for our industry. So the 3 ways, maybe more, I can only think of 3 ones, that the GDPR has been helping with this problem of providing data back into test and development environments. And number 1 is clarifying good practice. It's done so much for this. So I think people used to feel very unsure about what can I do, what can't I do, what's legal, what's not legal, and if I'm doing something which I think might not be legal, obviously, I don't want to put my business in that situation. And so I think lots of people didn't know whether the things that they were doing to mitigate the risks of using data were good enough. And honestly, we obviously still don't, because we don't know what those early lawsuits are going to look like. We don't know exactly what the enforcement is going to look like. But because the Information Commissioner's Office has put out so much information about how to comply with GDPR, we now have a bunch more information about what good practice looks like, what is considered good enough under the law. So for example, anonymization is held up. It's pseudonymization in the legislation. Like, it's actually there in the legislation as being a sufficiently good way to scrub out data, private data, as long as it's hard enough to go back to. So that question of that masking question, which technically is quite tricky. It's tricky to make sure that things still stitch together right and that things still actually behave like a normal database. So it's not technically that easy. But at least we know that if we do that anonymization of that personal data, that's given the okay in law. That's given the okay by the ICO. So there's been a bunch of guidance like this, which has actually done a world of good for people who kind of wanted to do something about it but didn't really know what to do. So that's really like unblocked people. The second one is that it like points directly to collaboration and automation. So the whole thing about DevOps and people trying to get traction for DevOps transformations in their business, well, this is actually essentially said these people need to work together. The data person needs to work as early as possible because of privacy by default and design, which is a great phrase, design and default. And so we have data protection by design and default, which is a key tenet of this legislation. And it says, under the GDPR, you have a general obligation to implement technical and organizational measures that show you have considered and integrated data protection into your processing activities. And again, for DevOps, like, yes, technical and organizational measures, yes. And this actually goes on even further to say that this needs to be baked into your process, should be baked in as early as possible. So very much that DevOps shift left, shift the data considerations as early as possible in the process. Yes. So all these, again, the data Bolsheviks are sitting there going, we are going to get our transformations. Everyone's going to manage this data well in the future. We will have no breaches. But it's pointing to that. And in terms of technical measures, most people would agree that the technical measures you can put in are exactly the things which sort of automate and make the thing repeatable so that you have your audit trails, so that you actually have a consistent and reliable way of dealing with data throughout your entire development process. So appropriate technical measures include all kinds of things like having documentation available for the database, and making sure that your database tables are encrypted and anonymized or pseudonymized. And obviously these are things which you can put in automated checks in your CI process to make sure that sensitive data still complies with this. Yes. So all of those things as appropriate technical measures get called out in the guidance. And finally, the fact that the GDPR itself is giving these things urgency and business significance. So it's pointing to DevOps and it's saying, these things are things that you need to consider now, that this isn't a thing for the future. This is something that you will get punished for. What is it, 4% of turnover is the penalty or something like that. Where, this is something where the business really cares about making sure this can happen. So far from the original assumption that the GDPR was going to mean that data kind of got restricted, that nobody could have any private data anymore. It's kind of gone the other way, and that it's put some sensible practices in place for the spreading of data in the organization and the management of it. So just to recap what we've been talking about, database and DevOps. So the database definitely can be part of your DevOps pipeline. And I know I did a real whistle-stop tour through how, but you can put your changes through. You can suck them into version control, put them through continuous integration, and validate them, and then push them out as the exact same change to progressively harden test environments. So it definitely can be a part of that. And managing the schema changes is a fairly well understood problem. Like I say, I think we know now that if you are going to go full DevOps, you need to be managing those migration scripts to take things from one version to another all the way through the pipeline. And we know that, we know how that works now. But bringing data back from production and trying to feed the pipeline, feed those environments is a harder problem. So that part about the closing the loop on DevOps, I remember that was what the talk was about, is actually some of the harder part. But some of the things, there's, again, some really interesting technological developments on. And in terms of that problem of spinning up those environments, so that's those three parts. Remember the ugly chart that has the making the database environments in the first place, where containers are really coming to the fore, and it, from where we're standing is looking like all Docker and Kubernetes all the way. Getting it to the right version, so applying changes from version control, and then making sure you get something realistic in it, some masked test data that can sufficiently simulate production, which raises new needs of doing this. And actually, so something that only just happened, I haven't even had time to put in the slides, is that Microsoft, so I work mostly on the Microsoft stack, that's what Redgate specializes in, we do a bit on Oracle and others as well. But they've actually started doing some things for data classification, which again, really unlocks a bunch of these problems. It means that you or I or anyone can actually code against this to make sure that we can classify information in development with the right level of the right level of privacy setting. We can use that to drive behaviors in the pipeline, to run the right checks and make sure that those, that a sensitive table is encrypted or whatever that's going to be. We can actually validate that and use that to drive downstream behavior. So they've baked that into SQL Server now in the version that they're just pushing out. So yeah, thank you. So there's some really brand new stuff. And again, this isn't something you have to have tooling vendors to do. A bunch of this are things that you can actually stitch together from the pieces that are out there and bring this into your pipeline and have it driving compliant behavior. And so yes, give us the ability to close the loop. And I actually have time for questions, which I thought there was no way I was going to have. So